In this video, I'm going to review some questions from standard level organic chemistry, starting with question 1. So you need to know the features of a homologous series, and we have 4 choices here. Number 1 is not correct. They differ by a CH2, that's correct. They have the same physical properties. Actually, they show a gradation in physical properties. Okay, so it should be gradation in physical properties. And then D, they differ in their degree of unsaturation. Unsaturation means that they have carbon-to-carbon double bonds. That's not true for a homologous series. So the correct answer there is B. Moving on to question 2. Which of the following pairs are members of the same homologous series? So you need to look for the group of atoms that represents the functional group. So here we have an OH group, and that will be joined to the carbon like this, and the rest of the molecule will be there. And then if you have CHO, what that is, that's an aldehyde group, which has the carbon to oxygen double bond, and of course the rest of the molecule. So they're not the same, they're not in the same homologous group. This is the alcohols, that's an aldehyde. B, you can see we have an OH group here and an OH group here. They are in the same homologous series, the alcohols. And this one here, that would represent a ketone. And then the COOH would be the carboxylic acid. And finally, we have a ketone again here. And here we have an aldehyde, which would be on the end. Okay, so the correct answer there is B. Right. So a similar question, which of the structures is an aldehyde? So an aldehyde is represented by a CHO when you draw the condensed structural formula. So this is an alcohol. This would be a ketone with a C carbon to oxygen double bond. This would be an ester, okay, where you'd have this, CH3, and the rest of the molecule. So for an aldehyde, we need a CHO, so the correct answer there is D. Okay, definition of structural isomers. The best definition there, they have the same molecular formula, but they have a different arrangement of atoms or the different structural formula. So that would be D. So question 5 is about boiling points, and you have to think of the factors that affect the boiling point. Well, obviously here we have different functional groups. So here we have an alkane, then we move on to an aldehyde, and then an alcohol. So which one, you have to think which functional group has the stronger intermolecular forces between the molecules, okay? So the alkane would be the weakest, that only has van der Waals forces. And then next would be the aldehyde, that has dipole-dipole. And then the strongest would be the alcohol, because that has hydrogen bonding. Okay, so VDW is van der Waals forces, DD is dipole-dipole, and H bonding is hydrogen bonding. So you have to look for the correct order, and it just so happens that we've got an alkane, an aldehyde, and an alcohol. So actually the correct answer is A. If you look at B, you've got the aldehyde first, then the alcohol, then the alkane. That's obviously wrong. C, you've got the alcohol first, alkane, and then aldehyde. And then D, you've got the alkane, alcohol, and aldehyde. So the only answer here that's correct is A. Moving on to question 6. And you have to identify if these alcohols are primary alcohols, secondary alcohols, or tertiary alcohols. So you look at the carbon, which is joined to the OH group. And then you look how many other carbons are joined to this carbon. So that's got 1, 2, 3. So that's tertiary. This one has 1 other carbon and 2 other hydrogens. That makes it primary. And this one has 2 other carbons and 1 hydrogen. So that's secondary. So the correct order is, number 1 is tertiary, number 2 is primary, and number 3 is secondary. So the correct order here is B. Okay, question 7 is about combustion and incomplete combustion. What are the products? So just a quick review. If it was complete combustion, it would be CO2 and H2O be your products. But this is incomplete, lack of oxygen. Complete is excess oxygen. Incomplete is lack of oxygen. So we're not going to get carbon dioxide. We're going to get carbon monoxide and water. Okay? Right. Moving on to question 8. Which of the following are isomers of pentane? So pentane has 5 carbon atoms, meth, eth, prop, but, pent, and it has 12 hydrogen atoms. So we start with 2-methylpentane. Well, that's pentane, which has 5, with a methyl group. With a methyl group is CH3. So that must have 6 carbons, so it's not that one. Methylbutane. Butane has 4, and methyl group again is CH3. And if you want to draw these structures out, you can. So that has 5 carbons, so that's 1. That's an isomer of pentane. And dimethylpropane, well, propane has 3 carbon atoms, and you've got 2 times a methyl group. So that makes 5 carbons, so that is an isomer of pentane too. So the answer there is 2 and 3, C. So question 9, describe a chemical test that could be used to distinguish between pent-1-ene and pentane. So pent-1-ene is an alkene, and pentane is an alkane. So what you do is you would add bromine water. You'd add bromine water to each compound. And the pent-1-ene will decolorize the bromine water. Pentane, the bromine water will stay brown. Number 10. Explain using equations the following steps in the free radical mechanism of the reaction of methane with chlorine. So we start with an initiation step. So we can do chlorine. So Cl2 with an arrow. You need to have UV light. And you're going to form 2 chlorine radicals. So that's the initiation step. And you could write the initiation or label it. Next is propagation. So the alkane is methane. So that's going to be CH4. And it's going to react with a chlorine radical. And it's basically going to take off one of these hydrogen atoms to leave us with a methyl radical plus HCl. And then the methyl radical, the dot means it's a radical, and you must have these dots. And that's going to react with chlorine. And we're going to form a halogenoalkane, which in this case is chloromethane. And you're always going to finish with a radical again, which can go back and start the chain reaction again. This is known as a chain reaction. And for termination, you need at least one step. So you could have this as a termination step. Or you could have the methyl radicals reacting as a termination step. And that would give you C2H6. And there's one more possibility, which is producing chloromethane. You need one of these. So you need the initiation step, 2 steps in propagation, and at least 1 for termination. Okay, moving on. We have the boiling point for the isomers of pentane. Here they are, A, B, and C. And the boiling point is 10 degrees, 28 degrees, and 36 degrees C, but not in that order. So which isomer has which boiling point? Well, it's all about the branching. C is the most branched alkane, the most branched isomer. That means it'll have a lower boiling point because the molecules cannot get close together. So the weaker van der Waals forces, so it has a lower boiling point. So C is going to be 10 degrees. And then B is more branched than A, so it'll have the lower boiling point. So that's going to make that 28 degrees. And then because this is basically this is the straightest isomer, that will be the highest boiling point, so that's 36 degrees. And the reason, you could say, talk about the branching. So C is the most branched isomer. And you could talk about the effect that has on the boiling point. So it has weaker VDW, van der Waals. Don't write it like this in exam. I'm doing it just to save space. Weaker van der Waals forces equals lower boiling point. And you can go on to talk about how the molecules cannot get close together because of the extra branches. Okay. Okay, so the names of isomers B and C. B is, let's have a look, the longest chain is 1, 2, 3, 4. So it's going to be something butane, and we have a methyl group, a CH3, and it's on carbon 2. So it's going to be 2 methyl butane. And the other one was C. So we identify the longest chain, meth, eth, prop. We could have meth, eth, prop, or meth, eth, prop. Doesn't really matter. So it's going to be something propane. And we have 2 methyl groups. Where are they? They're on carbon number 1, 2, 3. So this is going to be 2, 2. Oops. Should have a dash there. 2, 2 dimethyl propane for C, B and C. Okay, moving on. So moving on to part B, and in this question you have to describe which one has, out of C5H12 and C5H11OH, which one releases a greater amount of heat per gram. So the correct answer is C5H12, and the reasons why is C5H11OH is an alcohol. It's got this oxygen, therefore it's partially oxidized. And the second reason is pentanol, pentan-1-ol, has greater molar mass, therefore has fewer moles per 1 gram than C5H12 pentane. So moving on to question 12, you have to identify the formulas of the organic products A to E formed in these reactions here. So what we have here is an alcohol in number 1. It's CH3, CH2, and has 8 CH2s with an OH on the end. So that makes it a primary alcohol. And we're using acidified potassium dichromate. There's the H+, there's the potassium dichromate. And we are oxidizing to A. And then we're oxidizing again to B. So if you remember about the oxidation of the alcohols, they first oxidize if you heat under distillation to A. And if you keep oxidizing them, you heat under reflux, you get to a carboxylic acid. So to draw the formulas for these, for the aldehyde, we're going to have 7 of those with a CHO. If it's got CHO in the end, it's an aldehyde. And for the carboxylic acid, for B, we're going to have CH, 7, and then COOH, which is a carboxylic acid group. So that's A and that's B. In number 2, we have tertiary halogenoalkane. And we're going to react with sodium hydroxide, so we're going to have a substitution nucleophilic reaction, and because it's tertiary, it's going to be an SN1 reaction, and it's going to react to form a tertiary alcohol. So the condensed formula would be CH3, 3, COH. And that's the formula for the tertiary alcohol that's produced. Moving on to number 3, this is a little bit tricky. So what I've done here, I've drawn out the full structural formula. This CH3 in brackets means it has two branches coming off this carbon here. So this carbon here is this one here, and there's two methyl branches coming here, and we have a H, which is here, and the OH group, which is there, I put on the bottom there. So that's a secondary alcohol. The carbon attached to the OH is attached to two other carbons and one hydrogen. So we're oxidizing a secondary alcohol with acidified potassium dichromate, heat under reflux, there's your acidified, and we're going to make a ketone. So here's the structure of the ketone, and you could draw this like this, or you could have it like this. I think either one of these would be okay. And finally, E, we have ethene, and it's reacting with bromine. So the condensed structural formula would be BrCH2, CH2Br for E. And moving on, part 2, you have ethene can react to form a polymer. Name this type of polymer and draw the structural formula of a section of this polymer consisting of 3 repeating units. So the type of polymer is an addition polymer, and 3 repeating units would be this. And that's that. Moving on to question 13. We have 4 structural isomers of alcohols with a molecular formula C4H10O. Name each of the isomers A, B, C, and D. Let's start with A, methethropute, butan, and where's the OH group on carbon 1? So it's butan 1-ol. Moving on to B, methethropute, but this time the OH group is on the second carbon, so it's butan 2-ol. Moving down to C, the longest chain is methethprop, and it's on the second carbon, the OH group, so it's going to be propan 2-ol, but we have a methyl group, so it's going to be right here, 2-methyl propan 2-ol. That's 2-methyl propan 2-ol. And then we have D. Longest chain is methethprop, and it's on the first carbon. The OH group's on the first carbon, and the methyl group's on the second carbon. So it's going to be 2-methyl propan 1-ol. Okay, so we've named A to D. Okay, part 2. Determine the isomer that cannot be oxidized. So which one is the tertiary alcohol? This OH group here is attached to this carbon, and this carbon has 2 hydrogens and another carbon, so it's not that one. How about this one here? This OH group's attached to this carbon, this carbon's attached to 1, 2, 3 other carbons. So C cannot be oxidized because tertiary alcohols cannot be oxidized. Part 3, determine the isomer which can be oxidized to butanol, which is an aldehyde. So primary alcohols can be oxidized to aldehydes. So the correct answer there is A. A is a primary alcohol. So that would be A. Moving on to the next. Determine the isomer which can be oxidized to butanone. So secondary alcohols can be oxidized to ketones, and we have the OH group attached to a carbon which attached to 2 other carbons and 1 hydrogen. So that's secondary. So that's B. And the Part 5, suggest the structural formula of another isomer. So for this one, we'd have to draw the structure of an ether. So we have a CH3, an O, and then the rest of the molecule would be this. So this is one example of an isomer. And this is an ether. Okay, so moving on. Isomer A is formed by reacting with 1-bromobutane with aqueous sodium hydroxide, which is NaOH. State whether the reaction would proceed via SN1 or SN2. So it is 1-bromobutane. That is a primary halogenoalkane. Primary halogenoalkanes react via SN2 mechanism. So the correct answer will be SN2. So here I've drawn the SN2 mechanism. Important points to note is the curly arrows show movement of a pair of electrons. This is the nucleophile. The curly arrow must come from one of the lone pairs on the nucleophile. The transition state, I could label that the transition state, where we have both the OH and the Br negative attached to the carbon with square brackets and a negative charge. I should have this all in one line, but I ran out of space here. So we've gone from a primary halogenoalkane to a primary alcohol, and the Br negative is the leaving group, and there's your SN2 mechanism.